In a system similar to that shown in active figure 12.1, the gas in the cylinder is at constant pressure equal to atmospheric pressure, 1.01 times 10 to the 5th pascals, and the piston has an area of 0.1 meters squared. As energy is slowly added to the gas by heat, the piston is pushed up by a distance of 4 centimeters. Calculate the work done by the expanding gas on the surroundings. Work on the environment, assuming that the pressure remains constant. So this is an isobaric thermal process because the pressure under the cap is determined by the weight of the air, the pressure, external pressure, and it does not change as the gas is heated. So this is simply going to be pressure times the change in the volume, which is area, times height, which is PA delta H, or rather delta Y. So that's 1.01 times 10 to the 5th newtons per meter squared times 0.1 meters squared, so that'll just be newtons, times 0.04 meters, the distance that the piston was pushed up, which comes out to be 404 newton meters, or 404 joules. Now there's another question that I'd like to revisit later, and that's how much energy must have been passed to that gas in heat. And that would depend on one thing, on whether it's a monatomic gas or a diatomic gas. If that's a monatomic gas, then there would be 202 joules in the form of the heat transferred into the gas. 202 joules put into the gas as just straight heat, 404 joules as in the form of work, with the internal energy being 606 joules. With a diatomic gas, though, if I'm not mistaken, we would have 606 joules in the form of pure heat, with a total of energy exchange, or internal energy of the gas, would have had to have changed by 1010 joules. Now, that being said, I don't really want you to trust this calculation. I may not know what I'm doing. There may be a negative sign involved in here that I'm neglecting. Especially since this is the work done on the environment. The work done on the gas is going to be negative 404. So actually, if this delta U equals Q plus W is going to hold, and this is negative 404 joules of work done on the gas, and PV equals 2/3, let's call it KE. Kind of thinking of it as Q equals 1/3 of the KE, and U equals the KE. But it should be that the amount of heat inside the gas is increasing, the amount of internal energy in the gas is increasing, and the amount of work, or the work the energy added to the gas through work is negative. So there's going to be 3. So this should be positive, 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 negative. That's what I want to try to get with some clarity before I finish this project. But meanwhile, I'm just going to keep doing some more examples that I know how to do, because the book tells me how to do them, and then maybe I can come back to this later and see how it's supposed to be done.